Okay. Assalamualaikum and good morning. So my name is Ahmad Zakwan bin Ahmad Dawi. Nombor metik 11 DKA 19F 1067. Okay. Hari ini saya akan terangkan tentang determination of biological oxygen demand. Okay. So objektif dia to find the biological oxygen demand exerted by the given sample of wastewater. Okay. So apparatus use BOD bottles, pipettes, conical flask, burette, beaker, dropper, BOD and BOD incubator, etc. So description: BOD is the amount of oxygen consumed by the organism in breaking down the waste. Alright. So next. Okay. Yep. Alright. So step 1: take 200 ml of sample in 2 BOD bottles and dilute it with distilled water by filling the water up to bottleneck. Okay. Right. 2 times. Okay. Close it. Label the sample as sample A and sample B. So this one is sample A and this one is sample B. Alright. So why sample bottle are completely filled up to the neck? Okay, so because the avoid missing bubble. Right, so next. Step 2. Add 1 ml of manganese sulfate, Mn and MnSO4 solution to bottle named sample A. Okay. Care should be taken to avoid bubbles. Okay, so next, step 3. Add 1 ml of alkali iodide azide solution to sample A bottle. Okay, close it first. Okay. Care should be taken to avoid the bubbles in BOD bottle. Okay. So next, step 4. Mix the solution by inverting BOD bottle upside down for 25 till 30 times and allow the precipitate to settle down at the bottom. So allow the precipitate to settle down for a few minutes. So wait. So step 5. Add 1 till 2 ml of concentrated H2SO4 carefully without forming air bubble. Okay, so step 6. Mix the solution by inverting the BOD bottle till all the precipitate dissolve. Okay, so next, step 7. Take 200 ml of sample in a conical flask using pipette. Okay. So next, step 8. take 0.025 Newton sodium thiosulfate Na2S2O3 solution in the burette. Okay. So next, step 9. Titrate the solution against Na2S2O3. Add starch when the color of the solution changes to pale yellow. Then continue the titration till blue color becomes colorless. So now, initial burette reading is 0 ml. Okay. So close the knot when the color. Okay. Add 1 ml starch into conical flask. Close the knot when the color of solution changes to colorless. Okay. What is normality of sodium thiosulfate solution taken? Okay, 0.025 Newton. Okay. So, observations. Alright, which of the following indicator is used during the titration? So, starch. Okay, correct. Alright, so step 11, keep sample B in the BOD incubator for 5 days at 20 Celsius. Right, and close it. 20 Celsius. Okay. Wait for 5 days. Okay. Alright, close. So why sample B is kept in BOD incubator? To prevent dual production via physiobiotic. Okay, step 12. Add 1 ml of MnSO4 solution to BOD bottle named as sample B. Right. Okay, sample B is kept in incubator at 20 Celsius. Next, step 13. Add 1 ml of alkali iodide azide solution to sample B. Okay, close. Okay. Care should be taken to avoid the bubbles in the BOD bottle. Okay, step 14. Mix the solution by inverting BOD bottle upside down for 25 till 30 times and allow the precipitate to settle down at the bottom. Okay, allow the precipitate to settle down for 3 minutes. Okay, next, step 15. Add 1 till 2 ml of concentrated H2SO4 carefully without forming air bubble. Okay. Okay. Step 16. Mix the solution by inverting till all the precipitate dissolve. Precipitate. Okay. So next, step 17. Take 200 ml of sample in a conical flask using pipette. Alright. Okay, so next. Alright, step 18. Take sodium thiosulfate and Na2S2O3 solution in the fluid. Okay, so close. Okay, titrate the solution against 0.025 Na2S2O3. Add starch when the color of the solution changes to pale yellow. Then continue the titration till blue color becomes colorless. So now, initial bullet reading is 0 ml. So open the knob. Okay, close the knob when it changes to pale yellow, and then add 1 ml starch into conical flask. Okay. Close the knob and change the colorless. Okay, next. So observation. Alright. Initial DO. Okay. Normal. 123. Okay. So let's say okay, so the answer is initial DO is 6.6, final DO is 4.8, so BOD of given sample is 270. So next, what is the acceptable range of biological oxygen demand in drinking water? So less than 6 mg per liter, right? So acceptable limit of biological oxygen demand in water is less than 6 mg per liter. Sewage disposed BOD level is less than 30 mg per liter. So if the value is greater than above a range, then it needs additional treatment before disposal. The water sample given as BOD level is 270 0.00 milligram per liter. So it is not in the BIS standards range for drinking water. Alright, that's all. Thank you.